Hello, and welcome to Scientific Terminology. Today we're going to be tackling chemical reactions, which is about atoms moving around and changing places in molecules and whatnot. So we're going to talk about all sorts of different parts of chemical reactions, and we might even talk a little bit about how we balance them. So let's get started. So what exactly are chemical reactions? Well, chemical reactions are when atoms rearrange themselves into new configurations, usually to lower the overall energy of the atoms. Atoms in general want to be at the lowest possible energy state because being at a higher energy state, you could just think about it yourself, right? If you're feeling really amped, you might feel uncomfortable, so you want to relax. Atoms are the same way. They like being in a relaxed energetic state. There are many different types of chemical reactions, and each kind has nuances that make them slightly different, but they always involve the rearrangement of atoms. Chemical reactions can also release or absorb heat, and many reactions can create dangerous gases and chemicals, right? Which is why safety is always a concern when you're having a chemical reaction going on. It's also important to always, like I said, use safety equipment when being around chemical reactions and have the kind of proper safety training to make it safe. So what are some of the types of chemical reactions? Well, there's several here listed. We've got single replacement, double replacement, synthesis, decomposition, combustion, acid and base, and redox. I'm going to talk about each one of these a little bit so you get to kind of a sense of what they all are. And then we'll move on from there. So let's talk about each of these individually. A single replacement reaction is when one atom is swapped out with another, right? A single replacement, right? One atom is being taken out of something and being replaced. So if you take a look at these Legos here, right? We've got the purple and the blue one together, and the pink one shows up, and then the pink one takes the purple's place. That's a single replacement reaction. A double replacement is when you've got maybe two chemicals with two different atoms in it, right? Maybe like HCl and Na2O, right? And they're going to switch places. So the purple and the pink, right? Yeah, the purple and the pink switch places. That's a double replacement. It's a flip-flop. That's what I like to think about it as. Synthesis is where you take two things and you combine them, two or more things actually, and combine them to make something new. So in this case, right, our two reactants are being combined to make this brand new product, which is different and new. Decomposition is the opposite of that. That's when you have something big like this and you break it apart into individual pieces. So synthesis and decomposition are kind of like opposites of each other. Finally, a combustion reaction is something that happens with hydrocarbons. Hydrocarbons are things that are made up of hydrogen, carbon, and oxygen. So you can think of things like petroleum, gasoline, stuff like that. Those are all hydrocarbons. When they are combined with oxygen in a fire or with some heat added in, you get two products always. You get water and carbon dioxide. These reactions always happen this way. You get a hydrocarbon and oxygen, you add some energy, you get water and CO2. These ones are pretty easily to predict because they always have the same products. Acid and base reactions, there's a few different types. For one, there may be like a neutralization reaction, which is where you have an acid like lemonade and a base like milk, and they combine and they make water and a salt. What kind of salt? Depends on the things that you're combining. So this salt isn't necessarily table salt. It can be all sorts of different types of salt, which is really just a cation and an anion together. There's also buffer reactions, which are reactions that cause the pH of the solution not to change very much. So for instance, if you have this ion in something here dissolved and you add base to it, it's not going to completely turn into an acid. It's going to keep the pH around the same level. Those are buffer reactions. Your blood is a buffer. It's used to keep the pH of your blood at a certain level, because if it gets too acidic or too basic, that's bad, right? So your blood has a buffer system set up inside of it. Redox reactions are reactions where the charges of individual particles change. So for instance, right, in this reaction, sodium is being oxidized, which means that its charge is going up, while chlorine's charge is being reduced. It's going down. And so these ones, you're really focusing on the charges of the different particles instead of just what's going where. And here's a picture of a redox reaction here. It's really cool. You stick metal into a beaker with another aqueous solution with some metal in it, and then you get new metal forming. It's really cool to watch. Something to check out if you're ever in a chemistry lab. So how do we write down these reactions? Well, reactions are written in a very specific way, and that's because we like to keep track of these sorts of things when we're scientists. So reactants are going to go on the right side of the equation, while products go on the left. An arrow is used to represent an equal sign and can point either direction or both at the same time. And each chemical has its state of matter written in parentheses, subscripted after it's written. So for instance, you could have an aqueous solution, which means it's dissolved in water, a solid, a gas, or a liquid. Those are the four main ones. So here's an example. We've got copper chloride, which is dissolved in water, and we're adding some solid iron oxide into it, and it's going to make iron chloride and copper oxide. So that's an example of a reaction. Thank you so much for watching. There will be more things out and about that I'll come out, maybe about balancing reactions or doing stuff like that. But in the meantime, thank you so much for learning about chemical reactions, and I hope to see you next time with some more scientific terminology. Thanks again. See you next time.